All right, so this video we're going to go on to section 8.4, and some of the things that we're going to discuss in this one is we are going to simplify rational expressions, and that is going to be video 1. And then our second video, we are going to multiply and divide rational expressions, and that will be video 2. All right, so for this first video that we're going to do, we're going to just strictly stick to simplifying. All right, now, if you can simplify, then multiplying and dividing rational expressions becomes so much easier. So this is key to this section, all right, being able to simplify. All right, so now if we're going to be simplifying rational expressions, you need to know what they are. Now, we've talked about this in detail in the last few sections, but remember, a rational expression is a quotient of two polynomials. So we've done this before where we have f of x is equal to p of x over q of x, where both p of x and q of x are polynomial functions. All right, thinking about rational expressions, it's often easier if you can think about rational expressions as ratios or fractions or quotients, because everything that we do in ratios when it's just numbers or fractions with numbers is the same thing that we do here with rational expressions. If we have 4 over 6, we would not leave that as 4 over 6, but we would reduce it to 2 over 3 because we can rewrite 4 as 2 times 2, and we can rewrite 6 as 3 times 2. So these two cancels, and then we're just left with 2 over 3. So everything that we do, it's everything that we've done before. So it's really not anything new except for now that it is presented in a different way. All right, so this first video, what you need to be able to do is you need to be able to understand how to write your rational expressions into simplest form. Just like we did here, it's the same thing that we're going to do. All right, so if we look at this first one, there's nothing that we can cancel with x plus 1 over x minus 1, so that remains. That is its simplest form. If we look at this one here, well, the first thing that you should do is factor the top, so it'll be x plus 2 times x plus 1. This is x squared plus 3x plus 2 factored out over top of x plus 3. There's nothing that we can cancel, so that is its simplest form. All right, here, if you look at this next one, these are ones that are not in simplest form because we can reduce. This x over x squared can become 1 over x. This one here, the x minus 3 can cancel out, and we're just left with 3. And then this one we can factor out to be x minus 3 times x plus 2. And then the bottom one can factor out to be x plus 2 times x minus 1. And then the x plus 2's can reduce, and we would be left with x minus 3 over x minus 1. Everything I just did here is everything that we're going to do in this video right now. All right, so if you found that to be easy to follow, then this video is going to be simple. All right, but one of the things you need to know is just like with regular fractions, rational expressions need to be simplified as much as possible when they can. All right, so now let's go ahead and do some problems. All right, so what is x squared plus 7x plus 10 over x squared minus 3x minus 10 in simplest form? And then the one thing that we will need to do is we will need to state any restrictions on the variable. All right, we can't tell what to simplify as is here. Right, it's not as easy as it is when it's 6 over 4 that we can say, oh, well, we just need to reduce each of them by 2 and get 3 over 2. It's not that easy. It's the same thought process, but it's a little bit harder. What we need to do for this is we need to factor our numerator and our denominator. So this positive sign tells me that they're both the same. This positive sign tells me that they're both positive. So we can write x plus and x plus. Factors of 10 that add up to 7 are 5 and 2. Here, this minus sign tells me that they're different. So I can write x plus and x minus. Now we're looking for numbers that multiply to 10 that have a difference of 3, and then the larger number will be following the minus sign. So 5 times 2 multiply to 10, and 5 minus 2 is 3. So since this is minus, our larger number has to be followed a minus sign, so it's x minus 5 and x plus 2. Now, since we had the same expression in both, just like we could if we were to rewrite this as 2 times 3 over 2 times 2, we both have a 2 in each, we can reduce. Here we can simplify and reduce those. So then our final answer for this, after we reduce it, will be x plus 5 over x minus 5. Right now, when we're stating any restrictions, we're stating the restrictions on the original problem. So that means we cannot have a 0 in our denominator. So that means x plus 2 cannot equal to 0, and x minus 5 cannot equal to 0. Or else if they did, then we would have 0 in our denominator. So x cannot equal to negative 2, or x cannot equal to 5. All right, even though this was simplified and essentially taken out of our problem, we still need to use it when we're talking about any restrictions. All right? There's 2 more problems that we're going to do, and then we're done with this video. All right, so for this one here, we're just going to simply divide. Negative 6 goes into 24. That would be negative 4. X cubed over x squared is x. Y squared over y cubed is y. So this is its simplest and reduced form. And then it says state any restrictions. Well, here, if x is equal to 0, we would get 0 in our denominator, so x cannot be equal to 0. And if y is equal to 0, we would get 0 in our denominator. So x and y both cannot be equal to 0. And that's it. All right, that one we didn't have to factor anything out. We didn't really have to do anything. All right, for this one, we need to factor. All right, so first we're going to factor out the bottom. All right, we know that this is a difference of 2 squares. So it will be x plus and x minus. The square root of 9 is 3, so it'll be x plus 3 and x minus 3. Now, if you notice, in both of these, our x is positive. So I'm going to rewrite my numerator as negative 4x plus 12, and I'm going to factor it out so that way it is going to be a positive x. So that means I need to factor out a negative 4. And if I factor out a negative 4, I'm left with x minus 3. Minus 3 will cancel out with minus 3, so now I'm just left with negative 4 over x plus 3. All right, and the same thing as before, any restrictions goes back to the original problem. So x plus 3 cannot equal to 0, or x minus 3 cannot equal to 0. So x cannot equal negative 3, or x cannot equal to 3. All right, even though we eliminated that x minus 3, we still need to talk about it in our restrictions. All right, that is it for this video. One more, and then we're done with this section.